x of pi over 4, negative pi over 4. Okay, so this is my sign. This is good. All right, so here's tangent. There's one for the full cycle, remember? Length pi. And then if you keep going, let's do another, so all the way now to 3 pi over 2. So here, pi. That's that distance, so that would be that distance. I mean, you already have this, I'm just. So now, how are you going to get yourself? So before we start graphing transformations, let's talk about cotangent. Yeah, let's do cotangent before secant and cosecant. So remember the reciprocals.
Yeah.
So remember the reciprocals. So look, check this out. At tangent is 0 is 0. Okay, I have this point indicated. So what's cotangent of 0 going to be? What's the reciprocal of 0? Undefined. So right away for cotangent, since you have 0 for tangent, you're going to have asymptote vertical. Because the reciprocal of 0 is undefined. Okay. All right. So now you got over here, you got yourself tangent of pi over 4 is 1. What's the reciprocal of 1? 1. So cotangent of pi over 4 also 1, because the reciprocal of 1 is 1. Okay, so now over here, tangent of pi over 2 is undefined, because you have vertical asymptote. What's the reciprocal of undefined? Because that's going to give you cotangent. 0. The reciprocal of undefined is 0. So cotangent pi over 2, 0. Okay. Now, let's keep going. Well, over here I've left it out, but what would tangent, right in between pi over 2 and pi, what do you got? What's in between pi over 2 and pi, halfway? 3 pi over 4, right? So tangent of pi over 4, can you see it over here? What is it? Negative 1. What's the reciprocal of negative 1? Negative 1. So here, 3 pi over 4. You got yourself negative 1. Okay, now you're over here at pi. So tangent of pi is 0. What's the reciprocal of 0? Undefined. So cotangent of pi gets you an asymptote. It's undefined. So here is cotangent now. One full cycle for cotangent. One full cycle for cotangent. It's from 0 to pi. This is pi, but we got to leave
How can we relate that like super quickly when we're looking at tangent and cotangent? Like, the only thing that I see is like relevant is that vertical asymptote
It's removed.
has been.
Essentially, they're related is if you take the graph of tangent, shift it, let's see,
It's just 1 over, right?
pi over 2 units to the right, and then flip it over the x-axis, you got cotangent. You see that? Shift it pi over 2 to the right, so the asymptotes also shift, and then flip it across the x-axis. You got yourself cotangent.
Oh,
You see?
Like, flip it.
Yeah, so there, I mean, there's a lot of similarities. So we're doing tangent and cotangent because the graphs cosecant, sine, they're really different.
how much?
And secant, cosine, they're really different, but these are like related. You can see this as a close relation. Shift it over and then flip it over.
How much shift was that in?
Pi over 2.
Pi over 2 in the base graph of tangent?
Yeah, if you take tangent, and if you shift it pi over 2, it doesn't matter which direction. And then you just flip it over your x-axis, you got cotangent. Or over the, yeah. Okay, so remember from last time, so this period, what was the period here for this guy? Pi. Same thing here for cotangent, what's the period? Pi. Domain. Talked about this last time. All real numbers except for odd integer multiples of pi over 2. So,
Wait a minute.
did I write it out last time, or did I do some
No,
weird
it's
notation?
you.
What did I do last time? Oh, I said x is equal to a set of x to the set of all real numbers. This is what I did not remember. Real numbers except for x equal to, this is what I did. Plus minus pi over 2, plus minus 3 pi over 2. Remember that? Plus minus 5 pi over 2 and so on. Okay, and what can we do for cotangent? Domain is going to be equal to. So again, it repeats, right? This repeats over and over again in each direction. So, what are you looking at? So look, you have a asymptote at 0, you have an asymptote at pi. This repeats. So where's the next asymptote over here? 2 pi. 2 pi. Again, where's the next one? 3 pi. Good. And then the other direction? Negative pi. Negative 2 pi, negative 3 pi. So this is just integer multiples of pi. Set. Set of all real numbers except for x equal to plus minus, well, we have to start with 0. 0 plus minus pi plus minus 2 pi, so we're integer multiples of pi, yeah.
Can I take even integer?
No, because you miss like pi and 3 pi and all that. Oh, this is odd integer multiples of pi over 2. Pi over 2. That's all integer multiples of pi.
So if we wrote like closed brackets for like pi over 2, and then like we did that open thing we learned in algebra, where like, you know, like a line would end and then it would start up again on a graph, would that also work?
You mean interval notation?
Yeah.
Interval notation for this one,
Sorry.
if you want to see it,
Yeah.
you're not required to know this.
U, right,
this is complicated. Someone asked me, right, so this is saying is an integer, k is an integer, you gotta use all these fancy symbols here. K is an integer, you gotta go with 2k plus 1 over pi, comma, 2k plus 3, I mean, this is hard to understand. Yeah, and k is an integer here. Because there's, I mean, you're taking a union of infinitely many.
Right.
So you have to use some fancy notation, right?
Okay.
Yeah. K is an integer, it gives you all the correct intervals. Don't worry about that. You don't, I mean, it is possible to write an interval notation, but you're not required. Because you got to take a union of infinitely many. You got a question back there? Okay. So now, let's take a look at, oh, you know what?
Homework?
Let's pause for a second, because I forgot to mention what's happening Thursday.
Mastery.
The next mastery quiz class.
Blowing my brain out.
I almost forgot. So the next mastery quiz is covering graphing trig functions, and it's only sine, cosine, tangent.
Oh,
Yeah.
it's hella easy.
So graphing, so mastery quiz number 2 on Thursday.
Is it gonna be like super crazy ones like phase shifts, vertical shifts?
Yeah.
Oh,
Graphing
baby.
transformations of sine, cosine, tangent. One cycle. One cycle. One cycle.
So just like a cycle of 2 pi or a cycle of pi, are they gonna mark us wrong?
A cycle will depend on the period. For sine and cosine, it's 2 pi. For tangent, it's pi. Right?
Shit. Well, I do my homework.
So okay, so let's start graphing some tangent stuff. So look, in the homework now it says just graph one cycle of the given function and state the period. It's not talking about amplitudes, because for tangent and cotangent, there's no highest, there's no lowest, there's no amplitude, doesn't exist. We can talk about the phase shift and the vertical shift. I guess it doesn't want it, but we can talk about it. But it doesn't make sense to talk about amplitude for these two, okay? So, you want to do a tangent work? How about 13? Okay, so should I erase the master quiz info?
Sure.
Graph and transformation of sine, cosine, tangent. Okay, so now we're going to number 13. Let's go on to 13 on the homework. Because you know the evens. Graph y is equal to tangent of x minus pi. Okay, so first thing we're going to do is if you take some arbitrary point, where does it go? X, y. Where is it going to go? The coordinate transformation. We take some point in the graph of tangent, like we were talking about last time. Where does it end up? Where does it end up?
X plus pi over 3.
That's going to shift to the right, so it has an effect on the x coordinate. What happens?
Add it.
Add what? Yeah.
Pi over
because-
3.
Yeah, add pi over 3,
So-
because it's reverse, remember?
Yep.
Y coordinate?
Y.
Yeah, it's just y. No effect on the y coordinate. So, so yeah, let's erase this. This is one cycle, one full cycle for tangent. You only got 3 key points here.
Mm-hmm.
You got negative pi over 4, negative 1, 0, 0, pi over 4, 1. And you also have the asymptotes. So if you include the asymptotes, it's really 5 things. So the asymptotes move the same way the points do. The asymptotes move the same way the points do. So let's start with the points though. So you got negative pi over 4, negative 1. It's going to go where?
Durbin.
What's negative pi over 4 plus pi over 3?
Pi over 6. Negative pi over. Having
What's
trouble.
pi over 3? Here, first person to get it. What's pi over 3? Find these candies. What's pi over 3? If you want it, what's pi over 3 minus pi over 4? Huh? What's pi over 3 minus pi over 4? Because that's how, that's what the next one is.
Yeah,
You said pi over 12. You want it?
Some random ass.
So we'll try again.
Said the denominator is equal.
So it's pi over, so it's pi over 12, right? A third minus a quarter is a 12. Comma. Which is negative 1. Okay, what's the next point? 0, 0. That's a nice one to work with. It's gonna happen 0, 0.
Which pi over 3, 0.
And then, what's the last point we got? Pi over 4, 1. Where's that gonna land?
It should be 4 pi over 3. 4. No. 5 pi over 4.
First person to get it, if you want to get it.
No. Some random
What's-
unknown candy.
Pi-
It'd be 5 pi over 4, right?
7 pi over 12?
Oh?
Yeah. Yeah, because it's gonna be, it's gonna get a common denominator, 12, right? It's gonna be 3 pi over 12 plus 4 pi over 12 equals 7 pi over 12.
Oh, all right.
They're
I have
sealed,
my
right?
shit mixed up.
So, pi over 12. So now, what was that partial check you could do? Make sure that these are all the same distance apart, right? Make sure that these are all the same distance apart. So pi over 12 and pi over 3 are how many units apart? 3 pi over 4 apart. These two, are they pi over 4 apart? Should be. Just double check that. And then remember, it's just these 3 points, the asymptotes are going to move accordingly. So if you got a vertical asymptote and there's a horizontal shift, does it move? Yeah, you're going to move it the same way that you move the point. So if you want even, you could say, hey, negative pi over 2. Now, we'll just do it visually. I think it's straightforward enough. So, let's start with the points, then we'll do the asymptotes. So, pi over 12, negative 1. So, alright, pi over 12, negative 1. So, let's say there's a pi over 12. And then we'll call this negative 1. Down there. So pi over 12, negative 1. 3 times, okay, then pi over 3. So 1, that's pi over 12. 1, 2, 3 times that. That would be pi over 4. Pi over 12 plus pi over 4. Pi over 12 plus pi over 4 is pi over 3. So that's all good. And then another 1, 2, 3. Will get us here to 7 pi over 12. And then we're going to put 1. Call that 1. And the asymptotes move accordingly. So where is negative pi over 2 going to go, the asymptote? Negative pi over 6, good. Which would be right, it would be 2 units there. Negative pi over 6. So this would be asymptote right here. And then what about the other one? So I guess, it's good if it's unclear to actually like label it. And then what about the other one? Pi over 2 plus pi over 3 gets you to 5 pi over 6. 5 pi over 6, so that should be 3 away from this one. That should be 5 pi over 6. X is equal to 5 pi over 6. And then, yeah, it's got the same shape and everything. Unfortunately, I stretched out the x-axis. That's why it looks stretched out. Should be. Same shape and everything. Just shifted pi over 3 units to the right. Pi over 3 units to the right. So if you want, yeah, we can practice with, it wants the period, but we'll also practice with phase shift and vertical shift. So what's the period here? What's the length of a complete cycle? So you go asymptote to asymptote. What's the length? Asymptote to asymptote. Negative pi over 6 to 5 pi over 6. Pi. Good. Period is pi. Phase shift. This is the horizontal shift. Was there a horizontal shift?
No.
Horizontal. Yeah. So if you went to the right, it's going to be positive. So positive. Positive. 5 over 3. Vertical shift. Is there a vertical shift? No, it's a 0. So 15. So 15. Y is equal to 1/3 tangent negative 2x minus pi plus 1. Now again, really complicated looking, right? There's a simplification that can be made. Notice, what do you got? On the inside, you got negative 2x minus pi. You can factor a negative out of both of those, right?
Right.
So if you're off to the side, check, watch the simplification. So, tangent, if I factor negative out of both, what does that give me?
2x plus pi.
2x plus pi. Right? So ignore the stuff on the outside for a moment. That's what I got, right?
We could take out the 2.
No, remember I showed you that tangent is an odd function, meaning tangent of negative x is equal to negative tangent x. Okay? Now, it doesn't matter what x is. X can be anything. So I could have said, hey, instead of x, we could have used tangent, we could have used theta, y, whatever you want. Doesn't matter what that is. So regardless of what this is, doesn't matter. It could be x, it could be theta, it could be y, it could be any expression. What can I do? Look, tangent of negative of whatever the heck that is equal to negative tangent of whatever that is. Doesn't matter what that is. So I'm putting a box there for like whatever, for any expression. What can you do there? It's gonna be. What can you do? Yeah, I was gonna say, yeah, so you can pull the negative out, that's all this is saying, you can pull the negative out. So you get negative tangent 2x plus pi. You can pull the negative all the way out, yeah.
Are you trying to do the horizontal too?
No, I mean, I'm simplifying it. I'm turning two negatives in here into just pulling that negative out. Okay, so this is the same as, good. Negative 1/3 tangent 2x plus pi plus 1. Okay, so in an odd function like sine, tangent, cotangent is odd too, I forgot to say. You can pull a negative out. You can pull a negative out. Okay, so now that we've done that, let's take some arbitrary point in the graph of tangent. Let's see what happens when it comes up. A lot going on this one, huh? So, with this simplified version, let's see what happens. Let's talk about the x-coordinate first. Where's that going to end up? Tell me where the x-coordinate ends up. What are you going to do to it? What are you going to do to x?
Divide it.
Well, everything's reversed because it's on the side. Not only are the operations themselves reversed, but the order of operations is reversed. Think about how you would solve that for x. How do you solve 2x plus pi for it?
Pi x reversed to the left.
First you subtract pi, right? First you subtract pi. And then what do you do? Divide by 2. If you take 2x plus pi, subtract pi off, divide by 2, you got x, right? So subtract by pi, divide by 2. Okay? Remember, that's always reversed. Okay, and then what's going to happen with your y? Well, there's something else out there too. You're going to what? And then add 1. Good. Because there's stuff on the outside, it follows the order of operations and everything like that. Negative 1/3 y
Plus 1.
plus 1.
Nasty problem.
Okay, so let's take the 3 points. Let's start with negative pi over 4, negative 1. How are we going with that? for x here, right? So negative pi over 4 minus pi is negative 5 pi over 4. What's negative 5 pi over 4 divided by 2? What's negative 5 pi over 4 divided by 2?
What is it, 5/4?
Well, yeah, so it's negative pi over 4 minus pi, which is negative 5 pi over 4. But you gotta have that, because it's over 2. What do you get?
5/8.
Negative 5 pi over 8, right? Yeah? Are you double checking this?
You said, 5 pi over 4 in half.
No, it's negative, they're both, it was negative 5 pi over 4. Minus pi gives you negative 5 pi over 4, right? It's like, okay, it's like negative a quarter minus 1. It's like a quarter plus 1 is 5 quarters, but it's negative, so negative 5 pi over 4, have it. Negative 5 pi over 4. Okay, now,
Positive.
what happens to the y?
1 over 3 plus 1, which would be 2 over 3, which would be 4 over 3. 4 over 3? 4 over 3?
Yeah. Because it's 1/3 plus 1, that's 4 over 3, right? Yeah, 1/3 plus 1, 4 over 3. 0, 0.
Be 0, 1?
Well,
No.
yes, you gotta plug in
Hold on.
0, 0 and that.
It would be x minus, well, yeah, so that would be 0.
Where you at?
It would be pi over 2. It would be negative pi over 2.
We'll plug 0 for x, yeah. Negative pi over 2, comma. What happens with the y? 1. Okay, and the last one is let's see where this ends up. So pi over 4 minus pi is negative 3 pi over 4, right? Is it pi over 4 minus pi, right? And negative 3 pi over 4 over 2.
Negative 3 pi over 8.
Negative 3 pi over 8, good. And what's the other coordinate?
Be this negative 1, right? Negative 1, right?
Well, it's going to be negative 1/3 plus 1.
Oh,
So
right,
1
right.
minus 1/3, 2/3.
1, and then it would be 2/3.
And now just to double check again, I gotta make sure the distance these two are apart matches up the distance those two are apart. Okay, so what's the distance between those two? Okay, so this, put it over 8, it's negative 4 pi over 8. Negative 4 pi over 8 and negative 5, oh, they're negative pi over 8 apart, right? No, they're pi over 8 apart, right? Yeah, pi over 8, and then if I take these pi over 8 apart, take that, add pi over 8 to it. 4 pi over 8. Yeah, negative 4 pi over 8 plus pi over 8 is negative 3 pi over 8. Look, all I'm doing again, look, these two on the x quantities are the same distance apart as the x quantities. So I'm just making sure that's being respected. The x coordinate of these two are the same distance apart as the x coordinates of those two. Just a partial check. Yeah.
Do we always start tangent with negative pi over 4?
Yeah, so these are the 3 reference points I'm using, plus the 2 asymptotes. With sine and cosine, there was 5 reference points. But here, there's 3 reference points and 2 asymptotes, so there's still 5 things to consider, right?
Yeah, but we always start at negative pi over 4. Is that right?
Yeah, if you're using this cycle, which I recommend over some books and some people, I don't understand the reason behind it, use, but they insist on using this half plus the half you get over here.
Oh, yeah.
And they're like, okay, that's 0 to pi. And there's pi over 2, like, I don't get it. I don't get it. A lot of people use this, there's some people that use it. I think it's less common, but some people like insist on it. Yeah. Okay, so, think about where the asymptotes go now. So if you think about it, there's only, okay, it's a vertical line, right? An asymptote, there's only one transformation, that's type of transformation, that's gonna change it. Do you know what that is?
Shift it up.
Well, if you shift up, it's just gonna be the same
Very
line,
shift.
right? If you take a vertical line, shift it up, you end up with the same line.
It gets good.
If you stretch it vertically, you end up with the same line. If you compress it vertically, it's still the same line. So none of the vertical transformation is affecting. Now what about horizontal? What if you stretch it horizontally? Still the same line. Compress it horizontally, still the same line.
Oh, okay.
So what's left horizontally? Horizontal shift. And the flips don't do anything. You take it, flip it across the X, same thing, flip it across. Wait, actually, flipping it across the Y, I just realized, could move it. Yes, good, flipping across the Y, that's another one. So we only have to worry about horizontal shifts and flipping across the Y. Because, if you flip these the way it is, they'll land right back where they are. But what if it was what if it was this? If you flip this across the Y, it moves them, right? So you gotta worry about is horizontal shifting and flipping across the Y.
What I was thinking
Yes.
was shift it to the left direction and then flip it about Y axis and then move it up 1 unit.
Here?
That's how it should be.
Yeah, but if it moves up 1 unit, it just stays where it is. So you don't need to consider anything that's happening on the outside.
Even the +1, breaks the midline. So it's
No, I'm talking about the asymptote. It's just a vertical line, right? You take a vertical line, you move it up 1 unit, it's right where it was. It's in the same location, right? Because the line keeps going forever, right? So it really hasn't moved. So yeah, and then when you flip across the y-axis, that's when you got a negative on the inside. So when it comes to a vertical asymptote, all you care about is what's happening here.
Is it the negative before X or after X?
Well, here, let's see. So it only cares about what's happening in here. It only depends on what's happening with the x's, right? Which makes sense, because this is x is equal to negative pi over 2. This is x is equal to pi over 2. So if we ever asymptotes go, what do you think you're going to do? Okay, so let's get the points down first, then we'll talk about the asymptotes. Maybe in more detail, I'll let you think about it. Okay, so let's get these points down. So we're not using grid, okay? So Markov, all these are negative, huh? Okay. Negative 5 pi over 8. And then we got negative pi over 2. Remember, they're the same distance apart. And then we'll just go.
There's like no symmetry between like the x's like they are and other shit, so it's kind of weird.
And then let's see. Everything looks like
There is a
the
different
points,
variable.
they're above the x-axis. They got 1, 2/3, and 4/3.
Like,
So maybe I want to mark this off. Okay, so I'll say that's a third. I'll say that's 2/3. I'll say that's 1, and then I'll say that's 4/3. Going up by 1/3. Let's see, where are we now? -5 pi over 8 4/3. Here we go. -5 over 2 1. -3 pi over 8 2/3. So now I know it's going to look something like this. Or if you want to wait, you can do it after we find your asymptotes. But I do know this. It's going to look something like that. But to get it to be more accurate, I need my asymptotes. Here's some. Hey, I just realized something else you can do. Remember, I said these, the x-coordinates are the same distance apart, even with the asymptote, right? Right? These horizontally, they're the same distance apart as these two are, as these two are, as these two are, right? So here's another way you can find the asymptote. Like, okay, we confirmed that these were all a distance of, what was it again? Was it pi over 8? I don't remember now. Should I do it again in my head? Okay. -pi over 2, that's -4 pi over 8. Add an 8, that's negative, yeah. So these are all pi over 8 units apart, right? Right? So then what's going to happen with the asymptote? There's pi over 8 units in each direction from these two, right? Pi over 8 units. So what's pi over 8 units in this direction? Add pi over 8 to that, what do you get? -2 pi over 8, which is -pi over 4. So there's one. So x is equal to -pi over 4. And then pi over 8 in this direction, so subtract pi over 8 off. So that's -6 pi over 8, which is -3 pi over 4. -3 pi over 4. So x is equal to -3 pi. Now I'm starting to think maybe the horizontal stretching and all that does move it, actually. Yeah, it does. What am I saying? The horizontal stretching and compressing does move it. Because if that stretches or compresses, those are obviously going to move. So, okay, any of the horizontal transformations will affect your asymptote, but none of the vertical ones. Therefore, to have found these, you can simply just plug -pi over 2 and pi over 2 in here. Let's just check it. What's pi over 2 minus pi? Divided by 2 is -pi over 4. Let's try with the other ones. -pi over 2 minus pi is -pi over 2 minus pi is -3 pi over 2. Half of that is -3 pi over 4. Okay? So if your asymptotes, just plug -pi over 2 and pi over 2 in here, and it'll give you exact your asymptotes.
Oh, my brain.
And then double check it with what I did, the distance, everything's pi over 8 units apart. So check your work. Period. Everything's pi over 8 units apart. What's the period? What's the distance between -3 pi over 4 and -pi over 4? How many units? And then, what else do we got? We got phase shift. What's your phase shift? So think about where your, remember, this 0, 0, where did that go? It went all the way to negative pi over 2, 1. So what kind of a horizontal shift did occur?
Negative pi over 2.
Yeah, pi 2. And then what was the last one? Vertical shift. Vertical shift. Yeah, it's just gonna be this guy out here. We got shifted up 1 unit. Okay. Okay. Let's take a look at some kind of. So here's how you're going to come up with the graph of cosecant and secant. Which one you want to do first?
Cosecant.
We'll cosecant first.
Yeah.
Okay, so come with the graph of cosecant. You're gonna first start with the graph of sine, because they're reciprocals. So what does the graph of sine look like? You guys remember? So let's make this one blue and make the graph of sine. Okay. Yeah, so in green, what does the graph of sine look like? What sine is 0? And then we move over. Pi over 2, what do we get? What sine of pi over 2? What is it? 1, okay. Keep going, what's sine of pi? And then, let's do sine of, what comes after pi? 3 pi over 2. What's that? Negative 1, and then 2 pi. What do you got for 2 pi? What's sine 2 pi? So now instead of making it solid, I'm going to draw a dash, because I'm really just using it as a guide. Okay, so it's like this ghost curve. Think of it as a ghost curve. It's dashed. It's only will be used as a guide. Okay, so remember, sine and cosecant are inverses. So sine is 0 is 0. What's the reciprocal of 0? Undefined. Okay, so you get yourself vertical asymptote. Now, maybe I'll do this. Now, sine of pi over 2 is 1. What's the reciprocal of 1? What's the reciprocal of 1? So cosecant of pi over 2 is 1. They match up right there. They match up. Now at pi, sine pi is 0, so what's cosecant of pi? What's the reciprocal of 0? Let's keep going. 3 pi over 2. What's the reciprocal of negative 1? Good. So they match up there. And then finally, what's happening at 2 pi? asymptote again. Okay, so now what's happening between these asymptotes? I just have one point. Oh, I'm gonna make it blue. Okay. Cosecant, the asymptotes are red, the cosecant points are blue. So what happens, what's gonna happen in between these two asymptotes? I just have one point in the graph of cosecant, because I know a pi over 2 is equal to 1, so it matches up with sine. So look, so yeah, so think about it this way. So you're at this point, right? And now remember, they're reciprocals, and you care about the y coordinates. As you start here and you move to the left, what's happening to the y coordinates? They're getting smaller and smaller. What's the reciprocal of something that's getting smaller and smaller? Yeah, the reciprocal of something that's getting smaller and smaller is, what's like the reciprocal of a tenth? 10. What's the reciprocal of 1 over a million? A million. So it's getting bigger and bigger, right? Now what about from the other side? The y coordinates for sine are getting smaller and smaller. What's the reciprocal of something smaller and smaller? Something bigger and bigger. Now what do you think's going to happen down here?
Smaller and smaller.
But now they're all negative, right? So they're all negative, but their absolute values are getting smaller and smaller. So they're getting larger and negative, right? Cosecant. The reciprocal of something small and negative is something big and negative in it. So that's a full cycle for cosecant. So remember, you don't care about the green, it's all about the blue, and then the red is the asymptote. And then it repeats, right, in each direction. So copy that over. Copy that over. So now remember, this whole thing copy paste here. So over here, what am I going to have? Am I going to have this? Am I going to have this there or this there? The one opening upward, is it going to go there or is it going to go there? And the one opening downward, is it going to go there or is it going to go there? Where does the upward one go? Here or here? Here, because you've taken this, moved it here. So this lands there, that lands there. Okay, and it keeps going. So yeah, you use it as a guide. You use sine as a guide to get cosecant. So what do you think? Is cosecant odd, even?
Be the reciprocal of sine.
Yes, it is odd, because sine is also odd. I left some notes, but oh, I won't remember. Yes, so cosecant is odd because sine is odd. What can you say about its domain? What can you say about its domain? So cosecant x is symmetric about the origin. domain? Is it all real numbers? No, because there's asymptotes, yeah.
So just a question, when you're looking at a domain that has like an asymptote, like a vertical asymptote, like,
Yeah, those aren't in your domain. Any place you see a vertical asymptote, that's not in your domain.
so, how do we say that? Like, how do we say that it's a?
Well, the same way we're doing for tangent and cotangent. All real numbers.
Except for plus or minus pi, 3 pi over 2, negative pi
Yeah,
over 2.
except for integer multiples of pi. Except for x is equal to, so start with 0, and plus minus pi, plus minus 2 pi, plus minus 3 pi. Because that's where you got asymptotes. So it doesn't make sense to talk about amplitude because there's no max or min. Anything else? We talked like other functions. Domain, odd, I think that's it. Is cosecant ever 0?
Your range is not zero, so.
Yeah, in other words, is 0 in the range. Does it have any x-intercepts? Does the graph of cosecant have any x-intercepts? Because so far sine, cosine, tangent, cotangent, they had x-intercepts. Does it?
No x or y intercepts, right?
No, it doesn't. Why? Because sine is never undefined. The only way cosecant could have an x-intercept if sine was undefined, because the reciprocal of undefined is 0, but sine is never undefined. So sine is never undefined. So let's do, what problem should we do? 17. Okay, let's graph y is equal to negative cosecant x plus pi over 3. Oh, I forgot to also say the period. That's what I forgot to say. Is 2 pi, same as for sine. So it has period. Two pi. So it comes to graphing, just go from 0 to 2 pi. So erase all this. So if you have the graph of cosecant in front of you, you only have what? 2 reference points, but 3 asymptotes. Yeah.
Does the asymptotes ever affect the period?
Affect what?
The period.
The asymptote, does it affect? Yeah, because we're gonna go to find the period, we're gonna go asymptote to asymptote. Left asymptote to right asymptote, not to the middle one, right? 0 to 2 pi. Like we did with the tangent example. Remember, we went from the asymptote to asymptote to get, yeah. So let's do this one. So if you take some point on the graph of cosecant, see what happens to it. take x and do what to it? Subtract pi over 3. What about your y? What about your y?
Negative.
Negative y, good, because you just have that negative on the outside. Okay, so what's going to happen with pi over 2, 1? What's a half minus a third? 1/6, comma, oh, pi over 6, pi over 6, comma, negative 1, good. Then the only other point is 3 pi over 2 negative 1. And where does this go? What's 3 pi over 2 minus pi over 3?
Pi. Yeah.
3 over 6, 9, and then 2. What is it again? 7 pi over 6? Is it 7 pi over 6? Comma 1. Because you guys switched the sign on your y. And then now, we weren't doing this before. Maybe it's a good habit to see where the asymptotes go. Remember? So for the asymptote, you're just going to throw it in here. So x is equal to 0. So we'll just go like this. So these are the asymptotes now. So the asymptote x is equal to 0. What are the other ones? Pi and 2 pi. Okay. So again, you put it in for x. What do you get? Good. You put it in for x again. The next one, what do you get? 2 pi over 3, and then you put it in for x. What do you get? Yeah. Okay. So if you want, we could start with the asymptotes first for a change. Let's start with the asymptotes first. So if that is negative pi over 3 to get there, it's 3 of those. And then 3 more. In between, I have pi over 6. Okay, so I need to figure out the spacing here. So negative pi over 3 and pi over 6. How many units apart are those guys? They are pi over 6. Okay, so I'm going over by pi over, no wait, negative pi over 3 and pi over 6, not pi over 6 apart. They are negative pi over 3 minus that.
Dude, this
They're pi over 2. They're pi over 2. Yeah? So we're pi over 2. Okay. Starting at negative pi over 3, we're going to go pi over 2. That's how many pi over 6s? 3 pi over 6s. Okay. Yeah, okay. I think I finally got it. Yeah, maybe don't use graph paper. It gets confusing. Yeah, unless you're like really quick with working with fractions, it gets really confusing. So yeah, so now I'm what did I say, 1, 2, 3 to get myself over to pi over 6. No, yeah, 1, 2, 3, because that's pi over 3. So it's pi over 3. That's 2 pi over 3. Wait, what am I doing?
Pi over 6. Dude, you're making me more confused,
It's
man.
pi over 6 plus, pi over 2, right?
2 pi over 3 would be, so this would be like,
Oh, that's the one that, I see what I did. Yeah. That's negative pi over 3, and that's pi over 6 over here. Got it. Got it.
okay, so then I would be pi over 6.
Yeah, there we go. And then 2 pi over 3, because remember it goes asymptote, point, asymptote, point. So asymptote, point, I haven't even plotted the point. Let's plot the point. Here. Let's put it over there. So I got asymptote.
Dude.
Point, so pi over 6 is negative 1, followed by asymptote at 2 pi over 3. Followed by point, 7 pi over 6, 1, 1, 2, 3, 7 pi over 6, 1, followed by asymptote at 5 pi over 3. Whoa, it's barely enough space, huh? Barely. And then, yeah, so to be clear, I can label them negative 3, 2 pi over 3, 5 pi over 3. So now you know you're going to have these arches, right? So starting at this point, where is the arch going to open up to the left? Is it going to open up or down? It has to open up down because it said there's no x-intercept. So it has to open up down. And what about over there? Starting at that arch? Up. Period. What's the distance from the leftmost to the rightmost asymptote? 6 pi over 3, which is 2 pi. And then phase shift, vertical shift, what are these? What's the phase shift? Where did this asymptote end up? Vertical shift. So just got shifted pi over 3 left and flipped across the x-axis. So, yeah, we have done secant, so the homework's going to be due next Tuesday. Alright, homework will be due next